Welcome back. This is A level math S1, and today we're going to start with chapter 2, which is. So, in the previous video, we have already done chapter 1, which is permutation and combination. Now, we're going to move on to chapter 2, measure of central tendency, measure of spread, and graphical representation of data. So, this is chapter 2, so let's start it. Let's start. Okay, so let's start with measure of central tendency. So, what we have here is the mode, the median, the mean, the range, and yeah, this is what center of tendency is. Okay, so you know what is a mode? Mode is something which is being repeated, which I mean like having the most frequency, the, something that is repeated so many times. Like for example here 6 is the mode because it's been repeated so many times and it's been ticked 3 times. It has the highest frequency than any other number, so 6 is the mode. Okay, this is what mode, the value that appears most often in a set of data. Median is something, median is a middle number. You take, like for example, if we have a number from 0 to 10 and we need to find the median from these, from it, then we're going to use a formula, and then we're going to take the middle number. That middle number is the median. Okay, the middle number in a list of numbers ordered from lowest to highest. Okay, always remember, whenever we try to take the median, we always try to make sure that the order should be from lowest to highest in order to make it easier to take the median. Okay, so that's number 1 for us. Okay, and then number 2 is if the total number of observation is an odd number, then well, it doesn't matter if the total number is odd or even number. This is the formula. You need to use this formula. Okay, like for example, if we have okay, 1 2 3 4 5 6 7 8 9, we have 9, and then it's going to be 9 plus 1 upon 2, so it's going to be 10th. So position is, wait, it's going to be 5, not 10th. It's 10, then 10 upon 2 is 5, 5th. Okay, so this is the median, this is the middle value, so we have this answer. Whenever we have the odd number of odd total number of, whenever we have the when the total number of observation is an odd number, then it becomes easiest for us to take the median. Okay, because it doesn't give the value in decimal. But what happens if we get the total number of observation and in even number form? So it's get a little difficult for us to find it. We will still use this formula, but what happens next is, okay, so we have 1 2 3 4 5 6 7 8 9 10 11 12. We have 12, right? So 12 plus 1 upon 2 is going to be 13. Wait again. uh, 12 plus 1 is 13. 13 upon 2 is 6.5. So it's going to be 6.5. Okay, now we can just take this, since it's between 6.5 is, wait, 1 2 3 4 5 6 7 8 9 10 11 12. Okay, so it's 12. It can be, okay, let me just use a calculator. 13 upon 2 is 6.5. It's not 5.5. So looks like I've done the math error in here. So it's 6.5, and I've done wrong in here. It's wrong. Okay, so it's 6.5. So 1 2 3 4 5 6. So this is 6th, and this is 7th. So what is 6.5 in between these two numbers? How can we find it? So that's very difficult, right? So what we're going to do, we're going to take the, let's say we're going to take 6th plus 7th upon 2. Okay, so 6 is 4 and 7 is 4, so 4 plus 4 upon 2 is 10, 4. So this is the answer. This is the middle value. This is the median. This is the median. Okay, 5.5, actually it's 6.5. This is 6.5. Okay, then we have taken 6th and 7, 6th and 7th. Okay, and then we have, okay, 1 2 3 4 5 6 7. So we got 4 as a median. Okay, this is how you take it. Alright, then moving on, which is the median. The median is the total number of all the values divided by the number of values. Like for example, so we have this example, like for example, if we have 8 numbers, 3, 4, 5, 6, 7, 8, and we have been asked to find the median, I mean to find the mean, and by means, finding the mean means finding the average of these 8 numbers. Okay, so what is the average? The average is known as the mean. Okay, so we have these 8 numbers, we're going to add them we're going to add all of them, and then we're going to divide by the total number of 8. So we got 38.925. This is the average number of the whole number of combined and divide by the total number. This is mean. Okay, it's not rocket science, it's very easy. Then what we have here is the range. The range is the difference between the lowest value and the highest value. Simple. Range is equal to max minus min. Okay, so if you wanted to know what is the range of this, so we're going to take 46.4 since it is the most highest, and then we're going to take 25.2. So max minus min, and we got the range. Okay, so now let's start with measure of spread, and we are going to understand that what are quartiles. So quartile is basically there are 3 types of quartiles. Lower quartile, which means the medium of lower half. The medium overall, the same quartile, the same medium that we have been trying to find. We have been doing the questions, and how to take out the median. Median means middle value of the overall data set. So this is Q2, this is quartile 2. Okay, covering at least covering 50% of the data set. Quartile 1 cover at least 25%, quartile 2 cover at least 50%, which means medium is in here, and quartile 3 covering at least 75%. So Q1 is lower quartile, medium of lower half. First of all, whenever we try to find out the quartile, first we always start with the second one. We take the medium of the overall, we take the whole data set as and take the medium, as we all know how to take the medium. So the total is 11. There are 11 numbers. 11 plus 6 upon 2, 6. So this is the medium. So this is Q2. Then we try to break it down into 2 groups, 1 and 2. In here we're going to find the medium. So it would be known as Q3, quartile 3, and we will use the formula 1 2 3 4 5 5 plus 1 upon 2, third. So this is the median, the third quartile. The first quartile, we will use the formula as well, 5 plus 1 upon 2, 3. This is quartile 1, this is quartile 2, this is quartile 3. Okay, and always put numbers in ascending order, only then you can find the quartile. So this is the quartile. Q1 is lower quartile, medium of lower half. Q2 is medium overall. Q3 is upper quartile, medium of upper half. So it's all about medium. Okay, interquartile is subtracting the upper quartile by lower quartile. Q3 upper quartile minus Q1 lower quartile. Okay, now variance and standard deviation. Okay, variance and standard deviation. What are variance? Variance is let's suppose that we have this data set, and after finding the mean of this data set, we have taken out the mean. The mean is 10. Now we need to know that how much further are each data set are far away from the mean. So we're going to just subtract it. We got -8, -5, 0, -2, 5, 8, 10, and now we need to find the average distance of the data set from the mean. We could just add all of them and divide by 8, but since there are negative numbers in here, so it would end up having 0. Which is why we're going to square it in order to remove the negative sign, and these are the negative sign. Now we're going to add them up and divide by 8, and we got the variance. This is the variance. We try to subtract each data set from the mean, and then we try to square each of them and then add them all up and divide by the total number. So this is the variance. But the problem is that this number doesn't define anything, because the reason why we try to square these all numbers just to get rid of these negative signs. Okay, so how to get back? In order to do that, we will just going to square root it, and we will get the average. And this is how you get the average distance from the mean, and this is known as the standard deviation. And before this is the variance. So standard deviation is equal to under root of variance. So this is the relationship between these two. Variance is the average distance squared to the mean. Standard deviation can be roughly thought of as the average distance to the mean if it is the square root of the variance. Okay, variance. So these are the formulas. You can use any one of them. I prefer using this one or this one, because it really helps me to solve it. But if you want to do it fast, you can use this as well. Standard deviation is under square root of variance. Okay, so and you can and these and the and this kind of standard deviation known as whole population standard deviation. So basically there are two types of standard deviation. Is a normal standard deviation and the other is a whole population standard deviation. So this is the whole population standard deviation. Okay, yeah, okay. Now let's move on. Coding, it's not the word coding that we used to do in programming. It's this is another definition of coding, which means subtracting. You reduce each number in a group by a certain value. For example, the certain value is 2. You're going to subtract each number by 2. So 15 minus 2 is 13, 12 minus 2 is 10, 17 minus 2 is 15, 9 minus 2 is 7, 8 minus 2 is 6. And this is before coding, and before coding you get the mean. After coding you get the mean, and the mean are different. But the thing is, the variance and standard deviation will remain the same. After coding, the variance and standard deviation will remain the same, but only the mean will change. So that's the thing. And for coding we can use this formula, this one or this one. You can either use either one of the variance formula. It doesn't matter which one. You can use either one of them. So basically there are two formulas. Okay, but I just put the third one just to make sure that which one is most easier. You can use either one of them. Okay, so yeah. Now let's go to the questions. So this is a question: the age at which a child first walked to the nearest month was recorded for 8 children. The result was as follows: 12, 11, 16, 19, 20, 10, 12, 12, and 13. First of all, we're going to find the mean. We're going to add all of them and divide by 8. That's the mean. And for standard deviation, we're going to use this formula. So what we're going to do here, we could just use this one. Square each of these numbers and add them up, divide by n, and minus mean square. You can use this. You can use either one of them. I am going to use this or use this as well. Okay. Okay. So I've used this, and square each one of them, add them up, divide by 8, minus, and we already know the mean, so we're going to square them and then subtract, and you got the standard deviation. Okay, now let's go to another question. A traffic camera measured the speed x km/h of 8 cars traveling along a certain street with the following results. So we have this result, and this is a question of coding. So it's saying that adding all of them but subtracting this by 62. So we're going to use this formula, x minus a is equals to, okay, so this is the same formula which I've just showed you. This is the formula. Okay, so we're going to use this. So x minus a is 62, so adding all of them, getting the sum, minus a is instead of a we're going to write 62 multiplied by n. Okay, so we're going to just put it, we're going to add all of them. We got this, and so you got this answer. As for this one, whenever we're going to have these kind of and we got this square, so we're going to do it manually. There is no formula for this. Remember that. Listen to my voice carefully. There is no formula for this. You're just going to do it manually and take it each data set and subtract it by 62 and square it one by one. So 62.7 minus 62 square plus 59.6 plus 64 plus this, and the last one is 62.3, and then you're going to add all of them and you got this answer. So this is the answer. We already know how to find the mean and the variant mean. You're just going to add all of them. You already got this. You just take it out and divide by 8. And as for the variance, you're going to use the formula as I've previously told you. Okay, so I've used this formula. I can use either this or this. Doesn't really matter. Okay, I've used this. So square each one of them, sum all of them, and minus u square multiplied by n upon n. And you got the variance. If you want to know the standard deviation, you could just do the square root and you will get the standard deviation. Another question: 12 values of x are shown below. So these are the values, and find the mean of this. Okay, first of all, it's saying find the mean of this. Okay, so this is coding, and we need to find this. Okay, we need to take this. We need to find the value of this, and then we're going to just divide by 12, and you get the mean of this. So getting the summing all of it, and minus 76 multiplied by 12, and you got this. Then you're just going to take it and divide by 12 to get the mean of this. Okay, another question is a summary of 24 observation of x give the following information. Okay, so you got this and you got this. The mean of these values x is 8.95. okay, the mean of x only, not this. Find the value of the constant a. Okay, so you got 24 observation and you got the mean. Okay, then since you know the total number and you know the mean, you can just find the total sum of the numbers. So you're just going to do like this. Here you go. This is the mean. This is 24. You got this. Then you're going to put in here, and okay, so we need to find a, and we're using this. All right, so yeah, and then in this way we could get a. So part 1 is done, and then it says find the standard deviation of these values of x. Okay, so finding the standard deviation. Okay, since we need to find the standard deviation of this, we all know that we have to do the square root, so we already got this, and we're just going to put in here. Okay, so this is another thing. Okay, this one is different. This is another formula for, here you go, this is it, and we all know that standard deviation is the square root of var, right? So standard deviation is the square root of var, and this is the formula for coding. We can just use this or use any one of them. Okay, so we need to know this, and then divide by the total number minus u minus a. So in, yeah, a will be here, it will be subtracted to the mean, and then minus and the square. Okay, so this is the formula. So we're going to use in here, right here. There you go. You need to know a, mean minus a, which is 12. A is 12, you already know this, and then multiply 24.94, and you get the standard deviation. Well done. Okay, now another question. The question is the amount of money x dollar that 24 people had in their pockets are summarized by this and this. Find ex and ex square. Okay, in order to find ex, we'll use the formula, as we all know. The formula is, I just showed you already, x minus a and x minus a multiplied by n. We need to find this, right? And we already know this, so it's going to be minus 60, and then we know a, which is minus 36, and n is 24, and you will get this sum. It's very easy. So there you go. I've done the same thing as I've just told you, and you got this. Now we need to find this, and we need to do it. We can use the standard deviation formula, right, in order to find this, or you could just use the variance or standard deviation formula. So first of all, we're going to find the mean of this. Okay, the question is really a bit tricky. We need to calculate this, and we got this, right? So in order to calculate this, we're just going to use this, either the variance formula. Let's use the variance formula. Like for example, if I want to know the variance of, then I will use this, and then divide by n, and then u square, right? And that's exactly what I'm going to do. So right now I don't know the variance, I know that this, and I could just calculate this. So for u, I already know that this is 33.5. okay, so this is 33.5 square, and I need to know this as well, and the total number would be 24. So this is 24, and the variance, I need to know the variance. Okay, one simple trick which I just told you about, that always remember that before coding and after coding, the variance will remain the same. The variance will remain the same. Okay, it doesn't matter if you do it before, if you calculate before coding or after coding, the variance and standard deviation will remain the same, only the mean will change. So we can use this idea, we can just take it into our advantage. I'm going to calculate the variance of this one. I could just use this, and then this is after coding, this is before coding. So before it was this, and but after coding is, this. So I'm going to use, so after coding, since this is after coding, I'm going to calculate the variance using this. Okay, so yeah, so I've just put the formula for the variance, and here you go. I've just put this, and this is a, so it will come here, multiply by n upon n, and you have calculated the variance. Using this, I could just put in here, and then I could just calculate this as well. Same thing I done here. I have this, and this, and I've just calculated this. This is how you do it. All right. Okay, going to the next question. Ahmed noted the test marks x of 16 people in a class. She found, sorry, this is he, not she. This is he. Okay, he found that this you got this, and that the standard deviation of x was 6.5. One person did the test later and her marks was 72. Calculate the new mean and standard deviation of the marks of all 17 people. Okay, the standard deviation could be no, it would be new. Okay, so first of all, um, it says that the standard deviation was 6.5. Let's calculate the mean, right? 824 upon 16, we got this, and that says that 1% did the test later and her marks was 72. So we're going to add it, and we can calculate it. So we can just do it like 824 plus 72 upon 17, and we could get the new mean, right? This is the new mean, 824 plus 72 upon 17, and this is the old mean. Okay, we all know the mean. And then it says calculate the new mean and the standard deviation. For the standard deviation, we could just do like this, that std square, and since we got this 72, we're going to use this and we're going to also square it. So 72 square upon 17 minus u square, which is we're going to use the new mean, and the new mean is the new mean is 52.71. but the problem is that we don't know this, so we need to calculate this first. That's why we have done here, and we're using the standard deviation, the old standard deviation, in order to calculate this. And after putting all of this, you got this. Okay, so finding this, you just put in here and you got the values, right? That's exactly what I've done here. I just put in here and I got the values. Alright, let's move on ahead. This is another question. The value of x is in a particular set of data are summarized by this. The mean is this. Find the value of n. Okay, so I have this, and I have this, and I need to find the value of n. Okay, in order to find the value of n, I'm going to put a formula. This is a formula. Okay, and I'll only know this, and I need to know this. Okay, let me think. So I know 28.325 and find the value of n, right? I need to find the value of n, and I need to know this. In order to calculate this, I'm going to 24. Okay, so yeah, I've used this formula. Then I just divide n on both sides, and after dividing it, I just got this mean. So yeah, okay, I put in this way, and then this will cancel out, and you got the mean, and you put the values in here, and then putting all of them, and you just got this. Good. Okay, that was easy. And that's it. This is measure of spread, and this was measure of central tendency. And now let's start with graphical representation of data. Okay, so this is the question. A survey was made of the number of people attending church service at one Sunday morning. A random sample of 500 churches was taken. This is the whole graph, and number of people attending. We got these class intervals and number of churches. And okay, draw a histogram on graph paper to represent these results. Okay, now let's understand how to draw the histogram. So I have just write it down in here. In order to make a histogram, we must make sure that there are no gaps between the data. Histogram represent continuous data set. We will do minus 0.5 and plus 0.5 to eliminate gaps. Okay, we're talking about this. You can see that the upper boundary and the lower boundary are not same, so there could be a chance of having gaps. So what we're going to do, we're going to put minus 0.5 in here, and then plus 0.5, then minus 0.5, then plus 0.5, minus 0.5, plus 0.5, minus 0.5, plus 0.5, and so on. And we will get these. You can see here we just subtracted 1 by minus 0.5, and you got this, and just add 20 to 20 plus 0.5, and you got this. And you can see here that the upper boundary of this class interval and the lower boundary of this class interval are same, which means there would be no chances of having gaps when making a histogram. That's rule number 1. The rule number 2 is we will also need to calculate the frequency density. So frequency upon class width is the formula. Data for continuous variable are always given into a rounded form. A person height h gives as 168 cm measured to near centimeter. Okay, like in this way. See, the reason why we try to do this is, we always do it for continuous the data. We always do it for continuous variables, you know which is a continuous data set, which represent continuous data set. We must give careful consideration to class boundaries, particularly if we are using rounded data. Careful consideration to class boundaries. Okay, these are class boundaries. We need to give careful consideration, particularly if we are using rounded data. Okay, so particularly if we are using rounded data, we need to make careful consideration to class boundaries. They are very important. They know. So yeah. So draw a histogram on graph paper to represent these results. We need a frequency density, and we need to make sure that we convert this into this. We need this. Okay. Then we try to draw the histogram. Okay. This is how I have drawn the histogram. This is the whole image. This is the frequency density, and these are the class interval. And as you can see here, that there are no gaps. All right. And here's another most important thing, that whenever we try to labeling the x-axis, we can do in one form, 1 2 3, or two form 2 4 6 4 4 8 12 5 10 15 20. Right now I've done in I have used this 20 number. There's a difference of 20 to 280, then 300, 260, 280, difference of 20. So you can just use any one of these numbers, but you cannot use 3. No sir, you cannot use 9. No, these are the numbers that you can use when labeling x-axis. Okay, so to understand is, for example, if you are trying to start with like you have this graph and you're starting from 35. Okay, you're not starting with 0 or 0.5, or especially not from 0. You're starting directly from 35. So whenever you do, try to make a sign of like this. This tells you that you are starting from way, you're starting way ahead. Like it's like this. Like you're just going to put 0, and then if you want to start directly to 35, then you just 35, then 40, and then 45, and then 50. Instead of you're just trying to make all of it like 0, then 5, then 10, then you will get to 35. Instead, you could just put this symbol and then start directly with 35. Okay, like this. You're starting directly with 35, this way. Okay, that's it. This is the histogram, and then it says find the probability that in each of the 3 churches at random from the sample, the number of people attending was less than 61. This is a chapter of the probability, so I think you should watch that video if you want to know how this works. It says that 3 churches are chosen at random from the sample. The number of people attending was less than 61. Number of people attending was less than 61. Here you go, from here. Okay, number of people attending was less than 61, and so you're just going to add them up and then divide it by the total, which is 500. So I've done it like this. Three churches are taken as 278 churches, which means less than 61 people were attending. So 278 upon 50, then multiply 277, because one church is taken out, then as the same thing as with the total. And then another church is taken out, so 270 upon 498. You will go through this in the probability chapter or permutation combination. So go through that. Go through permutation combination, you will get the idea. Okay. Alright, go to probability as well. Now moving to the next one. The weight of 30 children in a class to the nearest kilogram were as follows. So this is the whole data. And create a group frequency table for these data such that there are 5 equal class intervals, with the first class having lower boundary of 41.5 and the fifth class having an upper boundary of 61.5. So what we're going to do, since it's saying that there are 5 equal class interval, 5 different class interval, in order to make 5 different equal class interval, we're going to first of all take the upper boundary, then the lower boundary, and divide by 5. You will get the difference of 4. So 61, like for example, 41.5 plus 4, it would become 45.5. First, this is the first class. It becomes the first class. The second one is 45.5 plus 4, then 49.5. The second one, like this. So we got 5 different classes equal. You can see that the upper boundary of this one is equal to the lower boundary of this one. So which means there are no gaps. And now we're just going to make a frequency table. We're going to do tally, and then we will get the frequency. And this is the answer. This is how you're going to make it. Okay, you will see that which of these are fit into the
particular class boundary, and then you just try to make a tally and then write down the frequency of that number, or maybe write down the frequency that how many numbers are fitting into this class boundary, and then Then we have this question: the weight in gram of number of stones measured correct to the nearest gram are represented in the following table. So we have this whole graph, and okay, weight grams, and okay, so these are the class interval, and as you can see they are not same, which means we need to do 0.5 and plus 0.5 in order to make it equal. It would be best if you do that in every in every question whenever there are no equal class interval. Okay, and we have these frequencies. A histogram is drawn with a scale of 1 cm to 1 unit. That's a different story. When we will do that later, which represent frequency density. A histogram is drawn with a scale of 1 cm to 1 unit on the vertical axis, which represent frequency density. That 1 to 10 rectangle has a weight 3 cm. Okay, so we're going to make a graph, right? Calculate the value of x and the height of the. Okay, this is the question. Calculate the value of x and the height of the 51 to 70 rectangle. 51 to 70 rectangle, which means we are using this, and it has a height of 3 cm. Okay, and saying the histogram is drawn with a scale of 1 cm to 1 unit on the vertical axis, which represent frequency density. Okay, so we just made this, got this. This is a class interval, and okay, so yeah, let's see here. Calculate the value of x and the height of the 5170 rectangle. Okay, first we try to calculate the value of x. We have used this class intervals. So yeah, and just putting this frequency density formula, and we got the value of x. Okay, and then it's saying calculate the height of the of this 5170 rectangle. We got the frequency. The frequency of this is 15. This is 15. And then we're just going to use the frequency density formula in order to find the height of this. So it's going to be 0.75, which means we can see frequency upon class width. The class width is 20. Okay, I just forgot to tell you about the class width, how to calculate the class width. You can see here 1 to 20, 21 to 40. Instead of, do not try to do like 20 minus 1, it will give 19. Instead, I think it would be, you will use these. You can just take 20.5 minus 0.5 and you get the class width. You do the same thing. This 20 class width, 40 class width. Take the upper boundary minus the lower boundary, and you will use these whenever you try to find the class width. Okay, do not use these because they are not equal. There's a difference. It would be hard for you. Maybe, who knows, if you could just make a mistake. So it's best to convert these to these and then try to find the class width. Then when you just try to when you are done with the class width, then try to find the frequency density, frequency upon class width of each one, and there you go. Okay, so the same thing here. The class of this 5170. So let's say 50.5. 70.5 minus 50.5, and you get 20. So yeah, there you go, class width. Okay, this is a graph. Okay, so let's move on to the next question. The following table gives the marks of 70 out of 75 in a pure mathematics examination taken by 234 students. These are the marks. Okay, they're not equal. We need to make sure we need to make it right. Whenever we try to draw a graph, we try to do that, right? 0.5 in here, minus 0.5 in here, and plus 0.5. And then we got the class width. This is the frequency density. Okay, what did they ask? They said calculate the estimate of the mean mark and the standard deviation. Whenever you've been asked about the mean mark, so you will always try to find the midpoint of each of the class interval. This is a class interval. You need to find the midpoint, so you're going to do 20 plus 1, 30 plus 21 upon 2, or you can just write it down like 20.5 plus 0.5. It doesn't matter. So if I could just do it, if I could do 20.5, let me use calculator and then divide by 2, you will get 10.5. Same thing. It's the same thing whether you do it in this way, or you can just do it like 20.5 plus 0.5 upon 2. You will get the same value. Don't worry about it. Okay, so you have found the class, the midpoint, upper boundary plus lower boundary at the midpoint of each of this class interval. Then you're just going to the formula of the estimate mean is like this: fx upon f. This is the estimate mean. You're just multiplying by the midpoint of each of the class interval. In order to find the mean, first we will get this. Okay, we have already get this. Then you will use this formula: sum of frequency multiplied by midpoint upon total frequency. And this is a sample standard deviation. Like I told you from the start that there are two types of standard deviation. The first one was the whole population standard deviation, and this was the sample standard deviation, and it's a little bit different. It's always used when making an estimate. Okay, so the only difference is that you're putting -1 here and -1 here, and that's it. That's the difference. And another difference is your the frequency and the midpoint would be squared. And yeah, that's it. It's really easy. You can just use this one or just use this one. Okay, so you have calculated the mean, and then you just put this in. Okay, you put this in here, and you're just going to do it like this, and you got this answer. Okay, this is another diagram, and it's been said work out the mode, median, and mean. You can see the diagram in here, and those number which have the highest frequency is the mode. So 1 is the mode having the highest frequency. Okay, how to find the median? We're going to add all the frequencies, so they are total 20. Then we're going to 20 plus 1 upon 2. We're going to do that. 20 plus 1 upon 2. So it's going to give us 10.5, which means 10th is 10.5, which means 10th plus 11th upon 2. And let me see how I've done it. So this I've done it. You got 10.5. This is th. Then you just got this 10th 11 upon 2, and 10th and 11 are okay. You can see here that 0 has the frequency of 4. There are 4 zeros. One has the frequency of 6. There are 6, and 2 has the frequency of 4. So now we can just take the 10th and 11th number. So 4, 10. This is a 10. This is 11. Then 1 plus 2 upon 2 is 1.5 is the answer. This is how you calculate the median. Okay, and as for the mean, it's very simple. Multiply all of these by the frequency, and you will get the mean. This is difference because we don't have the class interval. So whenever we have the class interval, we use the estimate mean, and whenever you have the class interval, we just take the midpoint and then multiply that midpoint by the frequency, and you will get the estimate mean. Okay. Then we have these questions. Okay, now we're going to start with this question. The question is the weight of 220 sausages are summarized in the following table. So these are the class intervals. This is a cumulative frequency. Cumulative frequency is something that, like for example, that we have. Okay, for example, less than 20 weight, which means 0. Okay, which means none. Less than 30, so 0 plus 20, which add up to 20. This is telling us that between 30 and 20 the frequency is 20. Okay, between 40 and 30 the frequency is 30, but since it is saying that less than 40, so the less than 40 includes 20 and 30 as well, which make up 50. So you just added up all the frequencies in this order. So right now literally what this actually is, this interval should look like this, right? From 0 to 20 the frequency is 0. From 20 to 30 the frequency is 20. 30 to 40 30. 40 to 45 50. 45 50 60, and so on. And now you can see if I just write down like less than 30, then I will do 0 plus 20 20. Less than 40, then 20 plus 30 50. Less than 45, then 0 plus 20 plus 30, then it will become 50. Less than 50, then it will be 20 plus 30 plus 50, and Wait, less than 40 is 20 plus 30, 50. Less than 45 is 20 plus 30 plus 50, 100. Less than 50 is 20 plus 30 plus 50 plus 60, 160. 160. I hope you get the idea, right? So whenever you have been written like this, you're just going to convert the like this, right? This is the class interval. Okay, this is the class width, this is the frequency, and then you can just easily calculate the frequency density. And now let's see what it has been asked, what we have been asked. State which interval the medium weight lies in. Okay, so the total frequency is 220, so we're going to divide by 2. 220 upon 2, and it will become 110. So 110. Okay, which means 110 is lies between it's 100 160. So 110 lies between in this class interval between 45 to 50. So it is in, so this is the median class interval. Okay, so this is the answer, 45 to 50. And then it says find the smallest possible value and the largest possible value for the interquartile range. Find the smallest possible value in the larger. Okay, so it says interquartile range, which means we need to find q1 and q3 as well. So q1, for in order to find q1, we will multiply this this total by 0.25. Okay, as I've just told you before that q1 covers 25% of the data set and q3 covers 75% of the data set. So we're going to multiply this by 0.25. And for example, for if I wanted to know the medium, q2, then I could have multiplied this by 0.50. It would give the same answer, 110. If I multiply 220 multiply by 0.50, it will give the same answer. So for q1 we're going to multiply this by 0.25, you got 55. Then 0.75, you got 165. And then you're going to see here that that 165 lies between here, 160 to 110. So it lies between 50 and 60. Yeah, it lies between this in this class interval. So yeah, and 55 lies between 40 to 40. Okay, it lies between 40 to 45, 40 to 45 interval. So now we have this interval, and then it says that find the smallest possible value and the largest possible value. So for the interquartile range. Okay, for the interquartile range, so we need to find we need to make okay, the largest is 60 and the smallest is 40. So we can make 4 possible class interval. Okay, so since we are doing minus, right? Okay, yeah, since we are doing minus, so 60 minus 40, or it could be 60 minus 45, or 50 minus 40, or 50 minus 45. Okay, so let's say find the smallest possible value and the largest possible value. So the smallest possible values would be 50 minus 45, and the largest possible values could be 60 minus 40. So this is the answer. This is the largest interquartile range, and this is the smallest interquartile range. So smallest and largest. So it's saying that 20 5 to 20 is, so 20 is the largest and 5 is the smallest interquartile range. So this is the answer. All right, now moving to the next question, or we could just do this question. So this is the question. We have this diagram, we have the class interval, we have the frequency, and we have also taken out the midpoint, and then we just made a multiplication, f multiplied by x. State the model class. The model class would be the one which has the highest frequency, is a model class. Okay, so the model class is this one. This is the model class because it contains, this is the model class because it has the highest frequency. Then it says state the class which contains the median. We have the class interval and we need to find the median. Then we will always try to multiply this by 0.50 in order to find the median, because we are making an estimate. We don't know that for example, if we in this interval where is the median. So we need to make an estimate of. Okay, so whenever we have these kind of question and we have class intervals, class interval, then and if they ask us about that what is the median, then we will always try to multiply the total by 0.50 in order to find the median, q2. Okay, as for q3 q1 multiply by 0.75 or 0.25. Okay, so 230 multiply 0.50. And as for this one, it says state the class which contains a median. So this is definitely not necessarily to do this, right? We could just multiply this by, since the total number is 65, so multiply this by 65 multiply by 0.50, and it will give, let me see here, 65 multiply by 0.50, and it will give 32.5, 32.5, right? And it lies between 26 and 51. So this is the answer. This is how you do it because you are making an estimation. All right, right. So this is it, and now it says estimate the range. So we're going to take 155 and 190, and then we're going to just subtract it, I guess. Okay, we're going to take the midpoints. We're going to take the midpoints of the final class minus midpoint of the first class. So midpoint of the final class is, this is the final class, this is the first class. You can just do the subtraction, get the range. Then it says calculate an estimate of the mean. So we all know how we do it, right? So we can just get the total of this and divide this by the total, which means 1 2 3 4 5 6 7. So divide by okay, we're going to divide by the frequency. So divide this by the frequency and you will get the mean. Okay, next question is the weight in kilogram of two groups of 17-year-old mix from country P and country Q are displayed in the following back-to-back steam leaf diagram. Okay, so this is the diagram. It says find the median and quartile weight for country Q. Okay, we're going to take, okay, it says find the median of quartile Q for country Q. So this is the country Q, and first of all you're going to take the whole data set, and how many are there? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24. There are total 29. So 29 plus 1 upon 2, 15th. This is the 15. Okay, now we got the Q2, we got the quartile, Q2. Now we need to find Q1 and Q3. So we're going to see from here, they are 14 plus 1, 7.5, 7 plus 8. So 7 plus 8 upon 2 is 2. So the Q1 is 2, and by mean Q, which means 72. Then we're going to find Q3 from this side and do the same process, and we got 8, which means 88. Yeah. So this is how you do the median. You find the median and quartile weight for country Q. You are given that the lower quartile, median, and upper quartile for country P are 84, 94, and 98 respectively. On a single diagram on a graph paper, to draw two box and whisker plot of the data. It's very easy. Here it is. So this is the box and whisker for country Q, and this is a box and whisker for country P. For country Q, you got the max, which is here, 105, 51 is here. Then Q1, this is Q1, this is Q2, and this is Q3. You just make a whole box. Similarly, you do the same thing in here, and voila, this is the box and whisker plots. And number 3 is make two comment on weight of the two groups. So which one is more heavier? I mean, which of the data are, since it says that the weight in kilogram of two group of 17-year-old mix. Okay, so which of these two people, either from the people from country Q are heavier, or country P are heavier? As you can see that it's more separated, but country Q is more separated, so heavier in P than in Q, weight more spread out in Q. Okay. People are heavier in P than in Q. So because weight are more spread out in Q, which means they are less heavy and they are more heavier because they have a huge quantity of heavy or of fat people. Okay, so this is done. What are outliers? Outliers, a data set may have a few values that are much longer or smaller than the rest of the values in the set. These values are called outliers. So outlier is a value that makes a huge difference. If it affects the mean but it doesn't affect the median. So an outlier may represent an important piece of data. Outliers affect the mean more than the median. Therefore, outliers that are larger than the rest of the points in the data set tend to make the mean greater than the median. And outliers that are smaller than the rest of the points in the data set tend to make the mean less than the median. Like for example, if you have this data set and this is the value which is so much further away, but it does make a huge difference. It changes it's affecting the mean, but it doesn't it's not affecting the median. So this is known as the outlier changing the mean but range, but not outliers changing the mean and the range, but median is ineffective. In a survey of 65 students were asked to record to the nearest kilometer the total number of kilometer in a particular week. The result are shown below. So these are the numbers. It says on a grid, draw a box in whisker plot to illustrate the table. Okay, so we're going to take the numbers from the left and try to this is how you make the this is how you make a leaf and tree diagram. This is a leaf and first you make a leaf tree diagram, then you try to find all the quartiles, then you make a box and whisker plot. Okay, it's very simple, not that difficult. It's actually been it's very similar to the one we have done before right now. So and then you just made this. Then we have this question: an outlier is defined in as any data value which is more than 1.5 times the interquartile range above the upper quartile, or more than 1.5 times the interquartile range below the lower quartile. Above the upper quartile and below the lower quartile. So we need to find whether any values are outliers or not by seeing this range greater than this 98 and less than -30. So show that there are no outliers. Okay, so in the interquartile range, 32 doesn't come in here, neither 50, neither -18. It doesn't come in here. A value which is greater than 98 and less than -30. I don't think that there is any kind of value. A value greater than 98, its maximum is 70 and less than -6, its minimum is 0.055. So yes, hence after seeing data there are no outliers, definitely. Maybe we really didn't, it wasn't necessary to write it down. No, we just need to know whether any data comes into this range or not. Okay, so now let's move ahead. So we have this graph, and and this is the table. So now you can see here, so whenever we have been given this kind of class interval, we always try to make in this way. Okay, 0.5 on -0.5 and plus 0.5. So you're going to make in this way, and then if you want, you can just if you have been asked to draw the cumulative frequency graph like this one, if you have been asked to draw a graph like this, then you will try to convert this into in this way, and then you just do it in this way. You try to find the cumulative frequency. Okay, you do in this way, and then you just draw the graph, which is cumulative frequency polygon graph. Okay, so there are two types of graph. We can join the points consecutively with straight line segment to give a cumulative frequency polygon, like we have done here, or with a smooth curve, no no line segment, but just making a smooth curve to give a cumulative frequency curve. The estimate from a polygon and a curve will not be the same as they coincide only at the plotted points. It's up to you whether you want to do it cumulative frequency polygon or with a cumulative frequency curve. But I think it would be preferred to do with cumulative frequency polygon. It's much better. It's much accurate. It's much easier to do it, to draw. So for the example of making this kind of, if we have been asked to draw this kind of graph, this is the example of this question. Let's do this question. The arrival time of 204 trains were noted, and the number of minutes that each train was late was recorded. The result was summarized in the table. This is the table. So okay, so it's already been done. Now we need to find the cumulative frequency, and also we need to make this as well, this interval in this way, in order to draw a graph. Explain why 0 -2 in this interval means about the arrival of time of train. since it says that that each train was late was recorded, but since it's in minus, these are uh, number of minutes late, so these are the number of minutes late, but since it's less than 0, which means the train arrived early. So 43 trains arrive early. The train was late and arrived early. Draw a cumulative frequency graph. So this was a cumulative frequency graph. You can either draw it with a cumulative frequency polygon or with a curve. Okay. So draw a cumulative frequency graph, and from it estimate the median and the interquartile range of the number of minutes late of this train. Whenever you have been asked to draw a cumulative frequency graph, so number one, if you have been given this kind of class interval, you're going to convert it to this. Okay, then you're going to convert this to this. It says less than 0.5, so 0.5, then less than 2.5, then less than 4.5, then less than 7.5, then less than 9.5, then less than 11.5. You just try to make like this, and you need to have a cumulative frequency, and then only then you can make a graph. So this is the cumulative frequency, and these are the class interval, right? These are the class interval. Okay, so draw a cumulative frequency graph, and from it estimate the median and the interquartile range of the number of minutes late of these train. So I have drawn this graph, and after drawing this graph, I just multiply the total by 0.75, which is Q3, Q1 and Q2. Like I got 150, 153, 51, 102. Then you just try to make an estimation, and you just see that what is the value. So this is 3.7, 2.3, 0.3, and yeah, this is how you do it. In the exam, whenever you're going to solve this kind of question, don't worry about the actual value of the about the quartile range, because there is a range of acceptable correct answer. For example, I just find out that that the Q3 is 3.7, right? So in the marking scheme, I think it would be range between 3.2 to 3.8, and if this number came in between, then it's the correct answer. This is how the checking works. Okay, you just need to make a clear estimation. And this was the cumulative frequency diagram, or you can call it cumulative frequency polygon graph. There are two types of graph: cumulative frequency polygon and cumulative frequency curve. And this was the example. Now this is frequency polygon. Supposing that you have been asked about to draw the frequency polygon. So in the frequency polygon, it looks something like this. You got the frequency, and you got the intervals. You got the intervals like this. Okay, and then you try to take the midpoints as well. So you have these midpoints, and you just make segment lines, and this is the frequency polygon. In a frequency polygon, a single point is used to represent each group. This point is plotted at the midpoint of the group and shows the frequency for the group. Okay, so yes, this is the end of chapter 2. This was the end of chapter 2, measure of central tendency, and measure of central tendency done. Measure of spread is done. Graphical representation of data is done. So chapter 1 is already done, chapter 2 is done, and next would be chapter 3 or 4. Okay, so thank you so much for watching, and I'll see you in the next video.